This podcast goes over what a histogram is and where it's used, and also something called percentile rank. So the first thing we'll go over is the definition of a histogram. A histogram is similar to a bar graph. It's used to represent numerical data. It shows clusters of data and it shows the gaps of things happening, shows the frequency of things happening. The main difference between a histogram and a bar graph is that a histogram uses bins instead of bars. So we'll go over the difference between the two, and I'll write that up as well. So a histogram, write this up, uses bins instead of or versus bars. And what a bin is the column that shows how many of a certain data share the same value. Okay, the next page has an illustration showing the difference between a histogram, which again uses bins, versus a bar graph, which you might be more familiar with. Okay, so the first one is a bar graph. It's a bar graph, and each bar represents a certain person's eye color. So you can see one person has black eyes, 5 people have blue eyes, 7 people have brown eyes, and so on. So it shows one category. Each of these represent one. Versus a histogram here. In a histogram, each bar represents a range of values. So as we can see in this first bar, 2 people or 2 students have a height between 145 and 155. Right here, 6 people have a height between 155 and 165. So actually the 2 people in this bin right here have a height between 145 and almost not quite 155. And the bin starts here at 155 to almost 165, which it explains right here. So it says the height of each bin shows the frequency or the number of students that fall in that particular category. So the bin is a range of numbers. Instead of one thing in a bar graph. For example, the eye color is one thing. It's not a range of values like the height is. So that's the main difference between a bar graph and a histogram. Now, one thing you'll be asked a lot is the bin width, and the bin width is just how wide the bin is. So here the bin width would be 10 centimeters. So it's just how wide the bin width is, how wide the bin is in a histogram. All right, in class you do a handspan investigation. We'll skip that for now. So that was mainly the difference between a histogram and a bar graph. The histogram has bins instead of bars, and the bins contain a range of values here. It shows how many fit into that range. All right, so now we're going to talk about percentile rank. Percentile rank is used quite often when they're talking about SATs and ACT scores, or where someone ranks, perhaps in a school and so on. So percentile rank is the percentage of data values that are below the given value. So let me write this up, percentage of data. Percentage of data values that are below the given value. So here are 2 examples. Here is a histogram where the bins, the frequency just is how often it happens. Down here is the score of a certain test. The first example says students with score A are at the 30th percentile. So right here, score A is this line right here. Let me use my line tool. Okay, so if you are student A at this particular line right here, you are at the 30th percentile because your score is better than 30% of the students. So wherever you are, to tell your percentile rank, you look at everyone below you. Okay, so if there's 30% below you, you are at the 30th percentile. Let's say you're right here, where student B is, and 80% of the students scored below you. So you are higher than 80% of the students, and that means you are at the 80th percentile because 80% of students are below you. So you look at what's below you, and you're at that percentile. Let's do some more examples. I'm going to skip this for now, I'll come back to this one. Let's do this one. Let's say there's 450 people out of 1,000 that scored at least 23 on their ACTs. Find the percentile rank of someone who scored a 23. So here's the 23, and 450 people out of 1,000 scored at least 23. So they scored 23 or better. So we have to figure out, at this percentile rank, how many people scored below us. Okay, so to figure that out, we know there's 1,000 people that took the test. So we take 1,000, and then from that we're going to subtract 450, and that'll tell us how many people are below us. Okay, so we have 550 below us, but it's a percentile rank, so we have to change this to a percent. So the first step is to figure out how many people are below you. Okay, so here there's 550 out of 1,000, so the second step is we're going to change that to a percent. Okay, so percent is 550, and we'll be dividing by 1,000. So what that means is that we are at the 55th percentile, because that's 55%. So again, if you are right here on the continuum, you are at the 55th percentile, because 55% of people scored below you. So again, the steps are figure out how many are below you and change that to a percent. Okay, last example. It says the data used in this histogram have a mean of 34.05. I'm going to underline the important data and the important words here, and a standard deviation of 14.68. Approximate the percentile rank of a value 2 standard deviations above the mean. Okay, so we have to first figure out where we are in this chart, and then figure out how many people are below us. So if the mean is 34.05 and we're 2 standard deviations above the mean, we're going to be doing some adding here. So the first step is we're going to add 34.05. We're going to add 2 standard deviations, just to figure out where we are in the chart. Alright, so if we add those together, we're going to get 63.41. Alright, so let's figure out where that is right here. So 63 would be in this bin right here. And here you can see the bin width is 5, because each bar is 5, so bin width. It looks like it might be 10, but 10 is 2 of the bars. So that here the bin width is 5. Here's where you are. You have to figure out how many people are below you to figure out percentile rank. So I'm just going to write the number of people in each bin. So here there's 2 people in this bin, 4 in this bin, 5 in this bin. Looks like 9 in this bin, 4, 4, 3, 3, 2, 1, 2, 1. Alright, so here's the frequency, the number of people. So if we add those all together, there's 37 people represented in this, or 37 data points, 37. I don't know if it's people. I'll just put 37 total, I guess. Okay, so to figure out percentile rank, we have to figure out how many people are below us. So we can either count how many people are below us, or we know that there's 3 people above, or including us. So if we have, if we add I'm sorry, there's not 37 total, there's 40 total. Okay, so there's 40 total, and there's 3 above. It means there's 37 below. So the percentile rank, there's 37 data points below where you are, 37 here. We're going to divide by the total, and we'll get about 92.5%. So if you are right here, you're in about the 93rd percentile, because about 93% of people are below you. Let's look at the next problem. Approximately what percentage of data values are within 1 standard deviation of the mean? Okay. Well, for this one, we have to figure out where that is. Where is 1 standard deviation of the mean? So 1 above and 1 below. So keep in mind that the mean was 34.05. So let's figure out the lower end value of that. So below, we're going to subtract 1 standard deviation, which was 14.68. And that will give us about 19.37. And then we have to go 1 standard deviation above the mean. So we'll take 34.05 and we'll add a standard deviation. And that gives us about 48.74. Okay, so let's round to the nearest whole number so we can find where they are on this chart. So this is about 19. Well, we can round to 20, I guess. We round up, so let's say 20 is about 49. Let's see where they would be here. So 19.37 would be about right here. So I'm going to round to this bin. And 48.74 would be about in this bin right here. Okay, so in that bin. Alright, so we have to figure out what percent is within these 2 lines right here. And remember that there are 40 data values in all. So we're just going to add up these numbers of these bins right here. So this looks like it has about 5. This is 9, 4, 4, and 3. I'm not going to add this one up, we'll just say everything below it. So it's between these right here. We'll add them up. And we want to know what percentage is within 1 standard deviation. So we add up all the ones within 1 standard deviation. And then we'll divide that by 40 to figure out the percent. So if we add these all up, we get 25. 25 divided by 40 gives about 62.5. So within this graph, about 62.5% of the data is within 1 standard deviation. So most of your data is right here. All right, to summarize, histograms have bins versus bars. So the bins contain a range of values. For example, there's 2 data points between 10 and 15, 4 between 15 and 20, and so on. Percentile rank is everything below you. So if you are right here, to calculate your percentile rank, you add everything below you, divide by the total, and you're in the 92.5 percentile, or 93rd percentile. If you have any questions, you can ask during class, or you can watch the podcast again, or read your book.